factors. Write each polynomial in a factor form by finding the greatest common factor. So here what we have in this expression, in the a, we have a 5x in the 5. But I'm looking here, what is the lowest degree of the variable? The lowest degree is x cubic. So now I want to write here a 5, and in terms of the lowest degree is x cubic. But because this is in a x5, I can make this like a x squared. X cubic times x squared. So that's how I can factorize this first term. Second term I can factorize is a 25, 5 times 5. 5 times 5. But in the terms of the lowest degree here, what I have x cubic, I can write x cubic times x. Times x. And the last one is a minus 20. I can write in the prime numbers of 5 times 2 times 2, but let me write 5 times 4 because 4 I don't have anywhere and I don't have any 2's. So I can write 5 times 4 x cubic. And I'm looking which factor is the same factor for all of them. Here is a 5 and x cubic. Here is a 5 and x cubic. But here I have 5, but here I don't have 5, so 5 is not a factor. Just a 5 for both of them, and x cubic is yes. Here is a 5 and x cubic. But here is a 4, 4 is nowhere else. So the common factor for this expression is a 5x cubic. And I'm looking now what remains. In the first term remains just x squared. So x squared. The sign is a plus in the second term. Second term is just 5x. 5x. And in the third term is a minus. I write a minus. Is a 4, just a 4. So we already factorized the expression in the a by finding the greatest common factor. Now let's go here in this example. I am looking for variables p and q, which are the smallest degree. The q, the smallest degree, is just a q here, and the p, I'm looking for p in a 5, p in a 6, p in a 3. P in a 3 is the smallest one. And now the coefficient 45, I'm looking what I can find. I have 45, 36, 81. All of them I see they have a 9. So I'm going to write with a 9. So I'm not going with the primes. So to make a little bit shortcut, I can write 9 times 5. The first one. And this one I can write in terms of the smallest degree q is a q. And q in a 3, which makes q in a 4. In second is a p in a 3 is the lowest degree, is a p in a 3. But because it's in a 5 here, I can write time p squared, which is p in a 5. So now I'm looking for minus 36. I can write like 9 times 4. 9 times 4. And now what I'm looking here is a q is the lowest one, so I don't have to do anything else, just a q. And p in a 6, in terms of the smallest one, p in a third is here, the lowest degree from the terms. P in a 3 times p in a 3, is p in a 6. And here applies 81, which is 9 times 9. 9 times 9. And this is in terms of the smallest q is a q times q. Q times q. And p in a 3 is p in a 3. And now I'm looking what do I have of the same here. The same, I have a 9, I have a q, and p in a 3. Here is 9, q, p in a 3. 9, 1 9, but the other 9 is not because I don't have in the other. Here is 4 and 5 is not the common factor. I have a q and I have p3. So 9 q p in a 3 is the factor for all of them. What remains in the first term? Remains a 5 being a 5. 5 being a 5. And I'm looking at what remains in the second term. Second term is the sign is a negative. Here is the coefficient is a 4. And I'm looking for the numbers. What remains is a p in a 3. P in a 3. And I don't see anything else. And I'm going in the last one. Remains this 9 here, but the sign is plus. 9. And what else? 1q is gone. This q, 9q. So this is what remains here. And just let me make sure is 9 and q. So we factorize a second expression under the b by the finding the greatest common factor.